Climate change is something that affects all of our lives, whether we're a student, a teacher, or a scientist. And speaking of scientists, I have a guest here with me today that can tell us a lot more about climate change, Josh Willis. Now, you're an oceanographer here at JPL, correct?
Well, I'm an oceanographer, but I study sea level rise and global warming and really how the ocean fits into that whole global warming picture. Global warming is happening because people are emitting billions of tons of carbon dioxide and other greenhouse gases into the atmosphere. Now, when they get there, these greenhouse gases cause extra heat to be trapped on the Earth. So heat that would have otherwise been radiated back out into space is now sticking around and warming up our planet.
Now, all that heat is trapped in our atmosphere, but is it also affecting the oceans?
It turns out that 80 to 90% of the heat from global warming is actually going into the oceans. So the oceans are really the big Earth heat bucket. That's where all the heat winds up going. It turns out that the oceans can absorb 1,000 times the amount of heat as the atmosphere without really changing their temperature all that much. And the reason is because of something called heat capacity.
Do you have an example that could maybe explain heat capacity?
Let's imagine that this balloon represents the whole Earth's atmosphere. So now my candle, my little lighter here represents the sun, so let's add some heat to it and see what happens.
Now, don't try this at home without adult supervision and proper safety equipment. Whoa! So, obviously, the heat capacity of air is very low because it didn't absorb any heat at all.
Well, that's right. Almost as soon as we put the candle to the balloon, it exploded. And the reason is because since the air inside the balloon couldn't really absorb the heat that fast, all the heat went toward melting the rubber. As soon as the rubber melted, the balloon explodes.
Ah, okay, cool. Now that's a good demonstration of the heat capacity of air. How about the heat capacity of water or the oceans?
Yeah, let's do the oceans. How about a water balloon, Steve?
Sounds great.
All right. All right, Steve, so this balloon filled with water represents the oceans, and my lighter here represents the sun. Let's put some heat on it and see what happens.
Wow. Obviously, it's absorbing a great deal of heat.
Right, so you feeling the heat there, Steve?
I am.
All right, but the balloon really isn't, because it turns out that the water can absorb so much heat that it takes the heat away from the skin of the balloon before the rubber can melt, so the balloon doesn't pop.
Excellent example. So the water has a tremendous ability to absorb heat, and if that's an analog for our oceans, that means our oceans are absorbing a lot of heat as well.
That's right, they sure are, Steve.
All right, well, global warming sounds like quite a problem. What can we do about it?
Well, the first thing we need to do, Steve, is really just understand the problem. Scientists all around the globe, including NASA scientists and here at JPL, we study data from satellites that measure the oceans and the atmosphere, and these tell us about how global warming proceeds and hopefully give us an idea of what the future is going to look like.
It sounds like a pretty serious problem. What is it we can do?
Everything that we do almost uses some kind of energy, and most of it's produced by burning fossil fuels, which release carbon dioxide into the atmosphere. We could turn off the lights when we leave the room, maybe power down that computer every once in a while and go outside, take a bike ride instead of getting in your car.
Well, thanks, Josh, for coming in and talking to us today about climate change. We really appreciate your expertise.
You bet, Steve. My pleasure.
All right, thanks much. To learn more about climate change and how NASA and JPL are studying the problem, go to climate.jpl.nasa.gov. And for more information about what NASA is doing in general, go to www.nasa.gov.